Yes, I just made a 4.
40.
Oh my goodness.
34, 40, 1 and 2. 1 and 2 especially, I didn't even try them because I couldn't figure it out. And that was the only area under 30. This is just a bad patch of home.
Oh my goodness, y'all. I'm so surprised. No. Okay. All right, how about, does anybody need 21? Let's do it like this. Anybody need 21? Okay. So C is 27 point. So you really have to read. You really have to read the problem to know what they're asking you. So be very careful. The rate of consumption of oil in the United States during the 80s in billions of barrels per year is modeled by the function where T is the number of years after January 1st, 1980. Find the total consumption of oil in the United States from January 1st, 1980 to January 1st, 1990. So I'm looking at a time of what? 10 years. And it tells me that this is the rate. So if I want to know, so rate tells me that it's already a derivative. I need to go backwards on that. I'm going to do the integral from 0 to 10 of 27.08 over. You just plug 10 in for. Well, the reason I knew you shouldn't is because it says the rate, so I knew that this was how many billions of barrels per year.
Per year. Plug in 10.
That's good. Right. Well, in this case, no, C is the rate. Like whenever you solve it, you get the rate. Whenever you plug in, you get the rate. So, right, so it would say, oh, well, that's billions of barrels per year, instead of just how many barrels over the course of the span of that 10 years. I always tell everybody, if you don't know what to do, always take a derivative or take an integral. Just do one of the two. That's almost always what you're going to do at some point. All right. Do you need me to finish doing this? This was calculator. So if I... Yeah, so did you do this by hand? Okay, so 27.08. Okay. Well, so if I'm doing this one, this is going straight in Y1 for me. And I'm integrating from 0 to 10. But if I had to do it by hand here, my U would be T over 25, which means my DU would be 1 over 25 DT, right? So I need a 25 outside the counter. So it's going to be 25 times 27.08. And then I've got the integral from 0 to 10, e to the u du. Follow me? I don't know what 25 times. So 677. But y'all do get used to letting your calculator. You sure? They did it by hand. They didn't use calculator. 332.965 billion barrels. Gotta get the units right. All right, does anybody need 23? You said no or yeah? 23? Oh, I thought I did. Maybe I didn't publish it. Oh, okay, try now. Is it there? Okay. How about 25? 1,000. Okay. And this was a hard one to kind of reason through on this one. No, 1,000. It took me a little while looking at this one and reading through before I realized what it was they were trying to ask me. So you've got this kind of funky graph. They love funky little line graphs. And I'm just going to kind of do this to show you what's happening. Because I had to break this into different sections. So it says, people join the line for a particular amusement park ride at a rate R measured in people per hour given by the graph shown. So again, this is R, which is my rate. So to find out about the number of people, I'm going to have to integrate area under. So it says there's 500 people waiting in line at noon. If the ride can take 1,500 people per hour, this is the part that I didn't interpret correctly. What this means is, so you've got all these people, right? They're standing in line. They're waiting on this ride. R is how fast they're adding to that number. That's coming from up here. But the 1,500 people per hour, this is a roller coaster. That's how fast they're getting on the roller coaster. So they're leaving the line. Does that make sense?
Yeah.
So they're standing in line at the rate of R, but they're getting out of line at the rate of 1,500 per hour. The steady rate they're getting off. Okay, so now that we know that, how many people are waiting in line at 5 p.m.? Well, you got...
That's how many that's 150.
Every hour.
No, at 5 people. Also.
No.
Yeah, that's what the graph says. Yeah.
Oh, I see what you're saying. Okay. Didn't we do trap for this? Yeah. That's the rate they're getting on, not how many people got on.
Well, if it's between 4 and 5.
Because this is a rate, I have to find the area of each trapezoid to know how many people it was.
All right, now where's 50,000?
Height's 1, because that's from noon to 1. Oh, you're right. Noon to 2. Are y'all following what I'm saying?
No.
Because I feel like I'm kind of being unclear. All right, so area of a trapezoid, height over 2. Right, if you look that first and I didn't look good, that's what Lainey was saying. Make sure you change it to 2, because that's going for 2 hours. All the others go for 1 hour. So this one's 1 over 2 times, and then it goes 1,500 plus 2,000. And then this one, a half times 2,000 plus 1,000. And then this is a half times 1,000 plus 1,500. Does that make sense? Do y'all see what I'm doing? Do you see why I'm doing what I'm doing? Okay. Okay, well, the reason I did was because it's just this, and I didn't know how to find the area under otherwise. So if it ever gives you the rate and it asks for a number, you're always integrating. If you start with a rate and they ask you how many, we're integrating. Yeah, I did. I just used trapezoid. I used area to integrate instead of the, because I didn't have an equation. So now what do I do? Well, I take each one of these. Well, that's what? Yeah. 3,500 plus, what is it, 1,750? Plus 1,500 plus, what is it? 1,250. If you add all of these together, this one, plus this one, plus this one, plus this one, plus what you started with. There was 500 whenever I started keeping track, right? I add all that together, then what do you get? 8,000. Well, there's not 8,000 people in line because what I haven't taken into account is that every hour 1,500 of them leave. So how many hours did this span? 5 hours. So I need to subtract out 5 times 1,500.
500.
Because every hour 1,500 get out of line. And it should give you, oh, I thought I already added that in. Huh. Right?
Not sure what I did.
Okay. Did you get the right answer? But it didn't work.
But if I took the rate at the hour, added it all together, added those numbers up, and then added 500 back to the
Okay, you took the rate at the end of each hour. It's not a constant rate, though. The rate's changing. So no, that wouldn't work. Now, if it was, but even between noon and 2, the rate's changing. Even though that's a straight line, right?
It kind of worked though. I think I'm just gonna subtract or add the top.
You got 1,500? 1,000 plus 500 is 1,500.
So I got 500.
Ah.
Oh, I wrote
1,156.5. Basic. We need to do it. A machine fills carton. How you write what out? Yeah, it's just chapel. It comes out. You'll have one that's either trap roll or ram. Usually ram's the preferred one. So what you got? Yeah. A machine fills milk cartons with milk at an approximately constant rate, but backups along the assembly line cause some variation. The rates in cases per hour. So again, I'm looking at a rate and not an amount. To define the amount, I'm going to have to integrate or trap rule or area under the curve or some form of that. Are recorded at hourly intervals during a 10-hour period from 8 to 6. And there we are. We have knife. Everyone goes by 1, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. Yep. So my width on each one, or my height of each trapezoid, is going to be just 1. So I can take that out. I don't have to do individual trapezoids. That's what I'm going to do. Yeah, that's still just an hour. We're in time. So we're just going to do 1/2 times, and then I'm going to take the first one, 2 of the second. Okay. What else? Okay.
So it's
Yeah, you can skip over 34. I'm sorry. 39? What, 39? 39 was a good one. The graph below shows the rate, again, this is rate, at which water is pumped from a storage tank. Approximate the total gallons of water pumped from the tank in 24 hours. Oh, this was a good one. Did you use squares?
Oh, I didn't. You do not want to know what I did.
So it says approximate. If I was doing this just because I would have been more calculus-y to do something like trap rule. But since it says approximate, I probably would have counted the squares up. Because I'm talking about area under there, right? And hopefully I would get one that's close to. One more camera. So I guess I did more of a rectangular or approximation, but using 50 times 6 plus I would find out how much each of these blocks are. Each of these blocks are what? 6 times 50, 300. So 3, 6, 9, 12, 15, 18, 21, 24, 27. I'm saying if each block's 300, then maybe this one and this one make up a block, and this one maybe make up close to a block. So I would get C. Is it? I just said each block is about 300 square units, whatever it is, and I've got probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, you do trap rule.
Oh, yeah.
What do you mean here? It's still based on endpoints here. So I would go from, I'd say 6/2 times this height is 50, this height maybe about 55 or 60. What else? 1 and 2. Oh.
I'm pretty sure I don't do that.
All right, but you said 39 was a good one, so what did you do? Did you really?
Well, I did like.
We did the 9 calculus way. Technically, though, calculus is area under the curve, so we didn't do it wrong.
I also did.
Oh. Yeah. The data for the acceleration of a car from 0 to 15 seconds is given. In the table below, if the velocity at t equals 0 is 5 feet per second, which of the following gives the approximate velocity at t equals 15 using the trap rule? Okay, well, let's just use the trap rule then. Am I equally spaced? 3, 6, 9, 12, 15, yep. So height is 3/2 times, and I'll do 4 plus 2 times 8 plus 2 times 6 plus 2 times 9 plus 2 times 10 plus 10. Does that give you the right answer? $80 times 1.5, 120, and it said yes. Okay. Wait. Oh. I just left the 0 off. I think I must have went to write it and then it didn't pick up the rest of the 0. Because it says that if the velocity at t equals 0 is 5, so I started with that initial velocity of 5, so I had to add that back in there. And then what? 1 and 2? I can't believe y'all didn't like the area under the curve.
Although one was needed because
You didn't have to do that.
think about number 1, if you take the area under the curve, it increases the area above. If you take the area under the curve, the shaded area above the curve.
It is. So if you did the integral of cosine squared from 0 to pi, it's the same as doing the top minus the bottom. Y equals 1. That's a function, yes. That touches. So we're looking for the area between the two curves, yes? And this goes over to pi over 2, and then of course 0. So I'm just going to do the integral. Calculator or non? That is why it's hard. Okay, if you had your calculator, could you do it? Okay. Yeah, because you don't know the antiderivative of cosine squared. Yeah, but you still don't know the antiderivative of sine squared. That's the problem. Yeah. I would say top curve minus bottom curve. I would say that you would be okay to use the calculator on this. I feel like cosine of 0 is 1. Cosine of, yeah. Yeah, I would definitely say you're not going to have to do an integral. That's my fault. Use your calculator on that one. But 2, you do know the antiderivative of secant squared. Oh, not sine squared. You're right. Trying to think, is there some way you could rewrite that? I bet you could combine those. Of 2, pi over 2. Well, half of pi is 3.14, so yeah. That's just pi over 2. All right, let's look at 2 because 2 might be fun. 2 looks like it could shape up to be fun. Negative pi over 3. Did they use symmetry on this one? Like, did they go from 0 to pi over 3 and double it? You don't have to. Just because it's a symmetric graph on the y-axis, you could really just find half and then double, but you don't have to. All right, I'm going to do top curve minus bottom curve. So 1/2 secant, why am I lagging like that? Secant squared t minus -4, shut up, sine squared t.
Doesn't matter what we do first.
Yes, top minus bottom. This is top.
Well,
This is bottom. No, but we will do with respect to, we will do that where we're left and right instead of top and bottom. Maybe today.
no, wait, no.
All right. Let's see if we can get this into something we could possibly integrate. Because I don't know the antiderivative of sine squared. So maybe, what if I make this, do what? The exponent? You can't do the exponent. Oh, you mean could we do this? Yes, you can do that if you want to. Same thing. But then your du is going to be cosine, and I don't have a cosine. But you could if it worked. But because these are added and not multiplied, this is really like this. What is going on? Well, because I can combine them if it helps me. I can split them up if it helps me. It's just one of those things where it gets really sticky. This is whenever it gets kind of bleh. I think I'm going to see, this may or may not work. What if I have a common denominator and I combine? If it lets you use a calculator, yeah. 4 sine squared, this may not help, I just wanted to see, over, oh, you know what, it needs a 2 also.
You don't get right. Exactly, yeah, that's what? Well, I never heard of it. I never heard of it. But what is that? Yeah.
Quiz, we'll just practice with this. Both things where I was saying, should I show you this, should I show you that? I think I'm going to show you both. And then we'll just practice with area between two curves for a while. We'll just camp out here and practice with it. And then, because that'll give you all the information you need. Yeah. Okay. So what I showed you yesterday, and it was just a quick little snippet, we talked about top curve minus bottom curve. Does that make sense to everybody? Okay. That's whenever my equation is written with respect to x. Okay, but the problem is sometimes it would be better for me, in other words, if I have this function, golly, it is lagging so bad. Look at that. Let's say these are my two functions. And I want to do this area. The problem is I don't have a top curve and a bottom curve, right? Do you see that? I have a left curve and a right curve. So in order to find the area between these two curves, what I do is I write each equation in terms of y instead of x. In other words, what you're used to working with is something like y equals x squared. If I wrote that equation in terms of y instead of x, well, that would be solving it for x, so it would be the square root. Come on, you dumb computer, the square root. The square root of x, or y. This one is in terms of x, this one is in terms of y. Does that make sense? See the difference? And so when it's in terms of y instead of in terms of x, all I'm going to do is right curve. This is where it gets a little confusing. Because what I'm doing is I'm taking it from the curve to the y-axis instead of from the curve to the x-axis. So it would be all of this minus the left curve, which would be this. See, it's, I don't know, it's just, no, it's my computer. This is still area between two curves. Depends on how the curves are written. It's in terms of y is a lot harder than in terms, just because it's not the way you're used to doing things. You do, but a lot of them they will give it to you in terms. For instance, number 3 in your homework. You could if they ask you to, but generally what we'll do is we'll look at the way the equation's given to us, and then we'll evaluate based on how it's given. We don't want to have to solve the equation. So in other words, number three looks like this. And it says x equals y cubed, and it says x equals y squared, and it wants us to find this area. And then it gives us this point of 1, 1. Well, if I'm doing this one, these equations are already solved in terms of y. Do you see that? So instead of changing them up and solving for y, I'm just going to leave them like that. Now, be careful because your bounds have to be in terms of y also. It is. I'm going to write that up again. Your bounds on your integral are y. Right? Because I'm doing it in terms of y instead of in terms of x. This is easy because these are both the same point. But here, since it's already solved for x, since it's x equals instead of y equals, I'm going to go from 0 to 1, and I'm going to do right curve minus left curve. So I'm going to do y squared minus y cubed dy. You could do this top minus bottom if you wanted to. But in order to do this one top minus bottom, I would need to say, okay, well, that means that y equals the cubed root of x. Come on. I'm going to have to restart or something. And that y equals the square root of x. So I could, but because there's more room for me to make a mistake, I could just come over here and do it in terms of y instead of in terms of x. So if you're in terms of y, it's right minus left. If you're in terms of x, it's top minus bottom. Your bounds have to be whatever variable you're in terms of. Does that make sense? We'll look at number 4. It does, but what would you probably do? Look at the way the equations are written too.
5.
What about 5? I would do top and bottom on 5. That's what I always look at is the way it's written, but it could be too that you have to determine what's best when we get a little bit further. Does that make sense? These should be a little bit easier for you in terms of they're not trig functions. 1/3 y cubed. Yeah. I can't do this all day. But yeah, it's 1/12. Easy, kind of. Some of these you're going to actually have to graph to see where the bounded. It'll say find the area of the bounded region. So if this wasn't shaded for you and you just graphed these two, could you tell what region they're talking about?
Yeah.
What's the region bounded by the two graphs? So it's going to be it's this computer, it's lagging. Every time I go right on it, it just lags. Okay, let me show you the second part. Pause the recording. Let's see if it works. I want to. Oh, and do number 10. Bless you. Should I do one that we don't have the graph for?
Number 10.
Okay.
Wait.
They're so nice and shaped this area for you so you don't have any trouble understanding. In a real life calculus problem, the problem would probably read something along the lines of find the area of region R that is bounded by the equation or the graph of y equals x squared, x plus y equals 2, and the x-axis. And you would have to graph each one of those equations and know that it was the area that was between the equations and the x-axis. So, it could be. All right, so what in the world can I do? Because there are several ways I could approach this problem. I hear top and bottom. I hear terms of y. Do right and left. You could. There's multiple ways you could do it. That's kind of the point that I'm getting to here. How are you going to do it top and bottom? All right, let me ask you this. And I'm going to set both of them up for you to show you what happens here. But let me ask you this. Either way you do this problem, you need to know this point. Do you agree or disagree? Right, right. So either way, I'm going to have both variables in terms of the same thing sometime. Oh, everybody okay there? So my question is, where is x squared equal to 2 minus x? I need to know what this point is. They didn't give us the point this time. Yeah, it doesn't say for sure. You're going to have to find them, so I just want you to make sure. It is 1, 1, but I want you to see what happens. Oh my, just, Brian, you're okay. Why am I getting 2 answers? It's a parabola. If this kept going over here and that line kept going, the other would intersect at -2, right? But this one is 1, 1. All right, so let's set it up both ways. Let's set it up in terms of x, and let's set it up in terms of y and see what happens. And I want to show you, because several of you said you couldn't do top minus bottom. Okay, as I look at this, there's not really 1 on top, right? But what I could do, this is actually a much easier one than it looks like. I could divide this area into 2. Because there's no missing space. It goes straight from the curve down to the x-axis, which is just a normal integral. So this area is just the integral from 0 to 1 of x squared. And this one, I'm going to do it this way, but it is a triangle, is from 1 to, what is this point? 2? Of 2 minus x. I could add those two together. That's way number 1 with respect to x. Because I don't have a top and a bottom, right? And it's not between 2 curves that way because there's no missing area on the bottom. That wouldn't be a top and a bottom one because it's not sandwiched between just 2 curves. But if I did it with respect to y, my equations change, yes? This equation is and this equation is so I'm going to do right minus left. But my bounds have to be on my y. So what are my y bounds? From 0 to 1. That's exactly right. I'm going from here up to here. And I'm doing right curve, 2 minus y, minus left curve, the what? This was so I could find this point of intersection here. Because either way I did it, I had to have it. Whether it was the bounds for my y or the bounds for my x, I had to have it. That point is what, yeah. Because like I said, most of the time you're not going to be given a graph. You're just going to say, like, look at the way 15 and 16 and those others are worded. Find the area of the regions enclosed by the lines and curves. And you have to draw it, and you have to find that area, and you'll have to find those intersection points. I like it too. Yeah.
Doesn't respect the y, so y.
Mm-hmm. You don't need me to finish working it? The antiderivative will be 2y minus 1/2 y squared minus 1/2 plus 1 is 3/2, so 2/3 y 3/2. And I'm going from 0 to 1. 2 minus 1/2 minus 2/3. A half plus 1 would be 3/2, right? And then divide by that. What's the antiderivative of this? No, it's okay. Did you get 5/6? That's right. Yeah. Sure. There's not a top and bottom here because in terms of x, it's not sandwiched between two curves. I had to split. If I want to do it in terms of x, I'm going to have to split it because I have this curve first, and the integral from here to here gives me all of this area. And then from here to 2, if I did the integral of this equation, it would give me all of this area, and then I just add them together. Well, if you didn't split it up, what would tell me how you do it in terms of that? It's okay, go ahead. Which equation would you use? X squared. So you're adding you subtracted the 2, you did like you try to do top minus bottom. I see what you're saying. The problem is if you think about the way the integrals work, because it always measures from curve to x-axis, right? So curve to x-axis here gives me this, right? If I just go to here. But where are you going to? Are you going all the way to 2? So if I go all the way to 2 with this parabola, right, then I'm actually, that's going to give me all of that area. And then if I took this, that's just x squared though. If I subtracted out this one, well then what I'm really subtracting out is if I go all the way to 0, please write. I'm literally steady just for, then I would be subtracting out all of the blue. So I'd just be left right. Because you have to remember what the integral does. The integral measures from the curve down to the x-axis. So if I subtracted them, if I did that and subtracted them that way, I'd have all that yellow minus all that blue, and that wouldn't work. Right. Y equals is top and bottom. X equals is left and right. You either have to split it up or you have to do left and right. Yes. But it depends, because if you look like, if you look at like number 4, if you did the area under that curve, it's going to be really, really hard. You'd have to do the plus and minus of the spread. That's going to end up getting hard to integrate in terms of that. Yeah. I went ahead and did the top and bottom. And I should get the same thing. I haven't shown you how, well, I guess I can. Yeah, when you have to split it up. $13 you'd have to split up, and you'd have to, because your top and your bottom curve swap places. Yes. So let me show you. Let me just talk you through it. You have, yes, you're going to have to graph these and look at them and decide, hey, where do I need, and that's where you're going to use that intersect on your calculator. Second trace intersect. This one does, but when you get to this section, it does not. See this 3 points of intersection? You have to use that. But here, look, just look. I want to make sure you understand how to, see, look how laggy it is. We make sure you understand how to split these up. So this one, I'm going top and bottom for sure. But my top and my bottom swap places. So I'm going to have to go from -2 to 0 with this one minus this one. And then I'm going to go from 0 to 2, this one minus this one. Work what out together. Well, I want you to try at least a couple. Yeah, let me give you your homework, and if you need another one, I'll work another one with you. I'm going to let you do all you want, buddy. It's always right my slide. Which one are you looking at? No, because those are going to give you, the integral will give you negative. It'll still beat you. Are you going to write those in terms of y? If you do right and left, that's in terms of y. They're already in terms of x. So I do top minus bottom on those.
Yeah. How come we're only like that?
A lot of it is referenced in the back if you go, well, and then BC. Yeah, chapters 9 and 10 are BC. And part of 8.
That's like,
It's yeah. I'm you serious, Clark? Nobody? Nobody got that reference. Thank you. Thank you very much. Russell and I have decided that we can't trust anyone who can't recognize our references of National Lampoon's Christmas Vacation at least 10 times a year. It is our favorite movie. We love it. I know. We reference it all. Are you serious? You serious, Clark? Okay, so after the AP exam, we need to watch that. It does have a couple bad words. As long as it's PG-13. It's not R. I don't feel like it's R. I'll see. Okay, I think we're gonna let's make this do. give you each night.
Then we gotta do that quiz.
We already did 3.
We can all do Friday. Friday, no, we don't have school. Okay. Then I really. Then I'm gonna hate myself on Monday. Number 4, all right, that's enough. We're good.
I don't remember the last time.